Now let's look at the rule for computing the inclusive OR, and this will be the addition rule. So here is the general addition rule for finding the probability of A or B, remembering this is union. OR means union. That will be the probability of A plus the probability of B, and then subtraction minus the probability of A and B. Okay, let's look at what that means. We'll look at this in terms of a Venn diagram. So first I'll draw some kind of space. Okay, and now let's say this is event A, and this will be event B. Okay, remember how you compute probabilities. To compute a probability, you take the number of ways, be the number of ways that B can occur divided by the total number in the sample space. So I can't remember which was A and B, but let's say this black one was B. Okay, the number of ways it can occur is shown as symbolically as everything inside of the black circle, because this will be B. I'll label it so I don't forget. Okay, notice this included some of the possibilities that were A's where they intersected. So when I take the probability of A, then I would take the number of ways that A could occur over the number in the sample space. Alright, so then I would be taking all of this, and it would also include that intersection. So when you think about it, you included this overlap once when you found the probability for B, and you included it again because you're adding, remember, when you calculated the probability for A. So this little section in here has been included twice. So that's not right, so you subtract it off. And remember that little intersection piece, that was A and B. But it's been counted twice by this addition, so you subtract off one of them, and then you'll have the right number. Because what you really want is the number of ways that A or B can occur divided by the number in the sample space. So this number is inflated until you subtract off the intersection. If you remember in the multiplication rule for AND, for intersection, we looked at events being independent or dependent. When we look at the addition rule for the set union or the OR, then we look at whether events are mutually exclusive. If they're mutually exclusive, so here are mutually exclusive events. They don't overlap. If they don't overlap, A and B is 0, so you don't need this last term, or the last term is 0. So let me write that out again. Okay. The probability of A or B, take each one, add them together, and subtract off the overlap. If they're mutually exclusive, then this reduces to the probability of A plus the probability of B. There's nothing to subtract, or what you subtract off is 0. So this is the special case of mutually exclusive events, and this is the general rule. Now here's an example for that general addition rule. We're going to compute the probability that the single card that we draw from the deck is either an ace or a black card, or it could be both. So A is going to be the event of drawing an ace, B is the event of drawing a black card. Okay, how many aces are there in the deck? 4. So the probability of drawing the ace is 4 out of 52. Now, how many black cards are there in the deck? Well, half of them are black and half are red, so that's 26. So here's the probability of drawing the black card. Now look at the overlap. What is the probability? So we're looking at the probability of drawing an ace that is also black. Okay, how many of the aces are black? Well, there are 2 of them. The spades and ace of spades and ace of club are also black. So there's two of them, and the probability of A and B is 2 over 52. So now we're adding. Oh, I'm going to show here that you could also use the multiplication rule to calculate A and B. Remember, the multiplication rule of A and B is the probability of A times the probability of B given that A has occurred. So what's the probability of A? It's 4 out of 52. The deal is that these are independent events. The fact that I draw a black card doesn't influence whether I've drawn the ace. So this becomes probability of A times the probability of B, which is 26 out of 52, and I end up with 2 out of 52, which I did in the first place by observation. So this was just a little digression to show that the AND rule can be used when you need to. You can use the multiplication rule for AND and compute it that way if your sample space is so large that you can't observe it. Note also a difference between this rule and computing the AND. When I look at the probability of A alone, there are 52 cards in the deck, and I found the number of aces. When I looked at drawing the black card, that was a probability of B alone. So it wasn't B given A. That's why there's still a 52 in the denominator. So now here we're going to apply the rule. The probability of A or B, probability of A plus the probability of B minus the probability of A and B. That's the general addition rule for OR. Remembering that OR means set union, and that's why we're using addition. Here's an example for the special case of the addition rule in which you have mutually exclusive events. So let's say we got a bag of 16 marbles and we have 2 greens, 10 snake eyes, a steely, and 3 blues. Okay, what are the individual probabilities? We've got 16 marbles, 2 of them are green. The probability of green is 2 out of 16. You know, it's better not to reduce your fractions until the very end. I wouldn't write that as 1 over 8 because things can cancel out, and it's nicer. Also, when you're going to add, you want all those denominators to be the same. So for the snake eyes, what's the probability? There's 10 of them, so 10 over 16. For steelies, 1 over 16, and blue, 3. There's 3 blue marbles, 3 out of 16. What is the sum of all these probabilities? It better be 1 because that's our whole sample space right there. Okay, now when I use the addition rule, note that there's no overlap. If I draw green, then I don't draw a steely. So the special case, all you do is add up the probabilities. What's the probability of being green, or drawing a green marble or a blue marble? It's the probability of the green one plus the probability for drawing a blue, and there's no overlap, at least not in this setup. And you can see here, if you change denominators to something else, then you'd have to change them back. So don't do anything with your fractions until the very end of the calculation.